angle in histogram. So we are given a histogram and we have to figure out what is the largest rectangle we can construct out of it. So let's take an example here. Okay, so suppose this is 0 1 2 3 4 5, and we have to figure out what is the largest rectangle. Okay, to solve this, what we will do here is we have to take few observations. Okay, so first observation is we have 2 here. Okay, and we can see, if we find a smaller guy, if I find a smaller guy next to it, we cannot extend it, right? We cannot extend it. So that is one thing. Now, next what we'll do is, next guy is bigger, right? So then this means we can extend this one, right? We can extend this one till here, like this, till the end. And even if it before also, if we had it have a bigger height, then we can extend this and we can get the heights. So what, let's try to do a dry run of what we will try to implement here is, uh, we'll take a stack of, we'll take a stack. So suppose this, here here we are taking a stack. Okay, and this stack will contain index and height. Okay, starting index and height. So first we got 2. Okay, so 2 has an index of 0 and a height of 2. Now what we'll do is we'll simply suppose, see, we don't have anything before 2, right? So we know, okay, let's put 0 2 in the stack. Okay, let's put 0 comma 2 in the stack. Next guy is 1 0. Okay, next guy is this one. So basically index is 1 and height is also 1. As soon as we get something smaller, we know that we cannot extend the previous guy. So in the stack we have 0 2, we cannot extend it any further, right? So what we will do here is we'll pop it out, and we'll say, what is the max area. So max area is height into width. So what is the width? The width will be starting index, and where we are now, we are currently at I1. So 1 minus 0, so 2. Okay, so let's create the max variable, and now it is saving 2. Okay, next guy is 5. So 5 is starting from, where? So 5 is starting from 2 and the height is 5. Okay, and before inserting it into the array, we'll check, okay, is the previous guy smaller? Is this guy smaller, right? Is this guy is not smaller than the previous guy, so it's okay. So this is not smaller, not smaller. Okay, so we'll index to 5. Next guy is 6. 3 6, again 6 is greater than 5, so insert 3 6. Now we have 4 2. See, now before inserting 4 2, we know, okay, now we cannot extend the last guy in the stack. Whatever the last guy in the stack, we cannot extend it. So what we can do here is we'll take this guy out. Okay, we'll take this guy out, and now after taking this out, we know starting index height is 6, starting index 3, current index 4. So 4 minus 3 1, so 6. So we can update this to 6. This guy went away. Okay, and again we will check it again, right? So this guy went away. Now we have 2 5. Again 2 is smaller than 5, so starting index is 2. Okay, starting index is 2, and 5 is there, so 10. Correct, 4 minus 2 is 2, so 5 into 2 10. So we can again update this to 10. So this is also gone, right? Now the next is 2. Next guy is 2, right? Okay, somewhere we had 1 also, right? Where does this one went? Okay, we forgot to add this one. Okay, and because this 2 got popped out because of this one, so this will be 1. Okay, now this 2 is greater than 2 is greater than 1, right? So we find a guy which is greater. So we have this 2 here, and let's try it, or let's simply put it here. So this will be again 2, but what will be the index? So index will be what is the last guy we popped, the index of that, because we know that this we can extend it till this guy. So index will be 1. So from here we can start. So we have extended it in the left direction. So left we have extended it. Next guy is 3, and 3 is greater than 2, so no need to stop this 2. So we can simply insert 3. So this will be again 5 comma 3, right? So we got this 5 comma 3 here. Now we know the max is currently 10, but our stack has still few guys remaining. So basically our stack have 0 comma 1, and this 2 is here, so 1 comma 2, and the last guy is 5 comma 3. So now we know whatever guys we have, we can extend it till the end, right? We can extend this till the end. So we'll simply take, okay, 1 into start index 0, end index n is was 5. So 5 minus 0, so that is 5, not max, gone. 2, 5 minus 1, 4, 8, no, okay. And similarly 3, 5, that will give me 3 again, so no. So we get the max index like that. Now we'll try to code this solution up. Okay. So as according to the question, we need a max area variable that will keep track of what is the current maximum. Okay, we need a stack, right? We need a stack, and the stack will be saving nothing but index multiply the start index, not the real index. Okay, start index comma height. Okay, then, and let's also save the now we have to go to each element, right? For let I equal to 0, I is less than n, and I plus plus. Okay, we went. Now we know we are currently at I. Okay, we are currently standing at I, and we have to check that the array, what is the last guy? Okay, what is the last guy which is already there in stack? So for that, stack length has to be greater than 0, right? Stack length has to be greater than 0, and let's not clutter it here. Okay, sorry, let's add it. And so when do we need to pop it? Okay, when do we need to pop it? If the current height, okay, what is the current height? Current height is heights I. If this guy is less than what? Whatever we have in the stack of top. Okay, stack dot length minus 1, we got the stack top. And what is the height? Height is the second guy, because stack is a pair, right? Now let's pop it out. We know now from this condition we know that the height is smaller, right? The current height is smaller, so we cannot extend the stack top anymore. So let's take const index and height of stack pop. Okay, so we pop the element. If there is multiple, then we can keep popping it. Okay, and we know the max area now. The max area that this guy, the guy we popped, can achieve is, let's do a math dot max first, and that will take max area, and the max area will be height height into the width. What is the width? So we know the starting index is this. Okay, and currently we are standing at I, right? I minus index we can do. So we got the max area. Okay, and after we have popped, right, after we have popped, we can simply say go and okay, after popping we know that current element is smaller, right? So we can extend it toward the left. So let's extend it toward the left. So once done, we can put the element which is currently there with us stack.push, and we can put start index and heights of I. Once this loop is done, we might get something remaining, right? Like this last three guys. So that might get remaining. So we'll say while stack.length is greater than 0, because this guy will get extended till the end. So we'll again say const index height equal to stack.pop, and max area, and max area will become math dot max of max area, and whatever height we got for the bar into what, into it is going till the end, right? So end is n and it starts from this index. Okay, no need to push anything, we are done. Simply return the max area. Done. Submit.